Welcome back, Physical Science 20. This is the last video in the PW3.1 section. So we're just about to find the critical angle. We'll look at what is the critical angle for flint glass when light travels from flint glass into air. So we're imagining this. So we have flint glass going into air. So the critical angle, the critical angle, theta c, is that angle which results in this. It being refracted at 90 degrees. 90 degrees. So what angle does that happen? So sine of theta c equals the medium in the where I'm going to, i.e. air. And no, of course, it doesn't have to be air. I could go from glass into water. And I think in the assignment, I have a question like that. So sine theta c is equal to 1.00 over, now flint glass, let's see, I think we looked up that one earlier. We had something to do with it earlier. Flint glass, 1.62. 1.62. So if I take 1 divided by that, I get 0.6173. And of course, I have the answer. What was the question? It's an inverse operation. So find the inverse button on your calculator and you'll be able to figure that out. 38.1 degrees. Okay? So that is that. Now, here's an interesting thing. When theta c is larger than 38.1, there will be total internal reflection. Exclamation mark. Right over there I put it. So yes, if I had that, so let's say I had coming in at 40, well, guess what? It would all reflect back at 40 and go back in the medium. So that's interesting. Now there's an interesting part of this too, and it has to do with, we hear about diamonds being so shiny. Well, if you look at diamonds, it has a very high index of refraction, right? 2.42. So if I was going from diamond into air, take a look at what happens there. Sine theta c going into air, starting in diamond though, and let's see, what was diamond again? 2.42. So let's see here, 1 divided by 2.42, that is 0.4132. So just doing this just for kicks, take the inverse sine of that, and look what we get. Look what we get. Inverse sine of that number, 24.4. 24.4 degrees, smaller. So what does that mean? So here is my angle right here, 24. Oh my gosh, so that is interesting. So that means like light at this angle, or let's get this right. So light coming in here or bigger, because at 24.4 it reflects here. So anything, you can see most angles that hit this surface in diamond will be reflect backwards. So all that light is reflected until, and it's interesting, that's why diamonds are shaped in these weird ways, because when they hit something, they will reflect, and there's one area where the light escapes, and it's out of this flat, I guess it helps if you actually see it. So reflect, until, ooh, all the light exits. And we get that sparkling effect, and really bright, really shiny, because all that light is added up, and it all gets concentrated at this part of the diamond. So that's why when we're looking at it here at our diamond, we see all of that bright light coming out. All right, so that's total internal reflection, and of course that occurs when our angle is larger than the critical angle, and that critical angle is the angle at which refraction happens at a 90 degree along the surface of the substance in which light is exiting. All right, So you should be able to do the assignment now, and we'll see you again.